them separately. So here forward bias it will be different. What that VI characteristics means, the VI characteristic gives the current, what is the nature of the current and then how much it is flowing. In some of the point what happens, nothing but the current will increases drastically. So at which voltage it will increases, and then in the reverse bias it will decreases drastically, at which voltage it will decrease, that and all we will discuss. So here in the forward bias, whenever I see the voltage and then current graph, the current will be in terms of what here? Milliamperes, and the voltage I will take here in this direction V. Now what happens means, in the forward bias, what happens to the depletion layer width will decreases. Whenever the depletion layer width is decreasing, and then we will connect for the P, what will connect here? Positive terminal and then negative terminal to the N type we will connect. Now whenever I am continuously giving the holes here, and then here I am continuously giving the electrons, then what happens here? Depletion layer width will decreases. And also initially there was a electric field before, initial electric field that was from N to P actually, from this side of holes will be there, from that holes to this electrons electric field is there. Now what happened, whenever I connected like that, then what happens, electric field is in opposite direction. Initially it will not be in opposite direction, whenever I am continuously giving the electrons and then holes here, at that time after some time it will be in opposite direction. At that time, due to the external electric field, what happens, nothing but here barrier potential will get dominated. Barrier potential will decreases, I said that depletion layer width also decreases and then barrier potential also decreases. So here whenever I connect this one, this barrier potential I will take here VB, barrier potential. Whenever I connect the external potential here, due to this external battery, the holes are continuously going into the P type and the electrons are continuously coming into the N type. Whenever these are coming in like this, then what happens, this electric field will get dominated and then a new electric field will be set up here. Because of that domination, what happening here, barrier potential is decreasing here. So here whenever the electric field is set up in the opposite direction, we are overcoming that barrier potential. Obviously before barrier potential was there, now due to the new electric field what we are doing, nothing but we are overcoming that. We are overcoming this barrier potential, then only the current flow is taking place. Otherwise what happens, nothing but it will stop, barrier will stop the further conduction of the holes and then electrons. Here this barrier potential is getting dominated, and after that only the current flow is there. For example, if you take the dam, any dam if you take, for that they will just do that, limits will be there, all the surroundings borders will be there. Now what happening, nothing but water is coming from the other dam, a very high flow up to the barrier, what happens, nothing but that will get stopped. Whenever the water is coming, still water is coming, more water is coming, at that time what happens, the water will overcome the barrier and then they will come outside of the dam. In the same way here also, whenever we have taken up to some limit, everything was okay, nothing was happening, everything was okay. Whenever I am continuously giving the holes here, then what happens, this electric field get dominated by the new electric field. At that time barrier potential will be overcome by using the external potential, and then further conduction will stop. So further conduction will start. So here whenever the conduction is starting, already we know that the forward current from where to where, P to N will be there, that is a forward current IF I have taken. Now here also whenever you see the graph, at that time the graph will be there like this. So what is this graph indicates means, up to here, up to this voltage, whenever you see you are increasing the voltage this much, but how much current is increasing, only this much of current is increasing, nothing but up to the electric field is getting dominated, then what happens, nothing but forward current also very less. Once this got dominated and then I cross this barrier, then what happens, nothing but current increases drastically even for the smaller change in the voltage. Before this much of voltage was there, how much current I am getting, only this much of increase in the current. Once I cross that barrier, that barrier voltage is known as the knee voltage here. Knee voltage or threshold voltage. In the dual nature also you have seen that threshold. After overcoming the threshold only what happens, photoelectrons will come out. In the same way here also, After overcoming the threshold voltage, then only conduction will starts with high value like that. So up to that what happens, nothing but the current will be very smaller, and after that immediately the current will rises. So this voltage is known as the knee voltage or cutoff voltage, otherwise threshold voltage. Now this value will be different for different materials. Here we need mainly silicon and then germanium only. For the silicon, that value will be 0.7 volts. For the germanium it will be 0.3 volts. Okay, I have already said the trick to remember that another values. What is that? Silicon value is how much? 1.1 and then germanium is 0.7. What are those? What is that value? You remember? What is this? What is this? You remember everything and then you don't know what you remember also. Potential energy illa, kinetic energy illa, energy gap. Band gap. I said silicon means immediately, whenever you see the silicon you remember 1.1, but what is 1.1 means we don't know. Energy gap, that is band gap. Okay. Now this is what here? Knee voltage. Knee voltage or cutoff voltage. You understand, right? So this is about the forward bias. In forward bias mainly you have to remember that I have given holes and then electrons from outside. Whenever I give like that, before I was having the electric field from where to where, nothing but N to P. Now whenever I am giving new holes here, at that time what happens, that electric field will get dominated by the extra electric field, and then what happens, barrier potential will get overcome. Up to barrier potential overcoming, then what happens, nothing but the current will be very less. It will be increasing only obviously, but very less as compared to the voltage. Once I cross the barrier potential, then what happens, nothing but immediately the current will rises. So that limit is what here? Knee voltage we call. Knee voltage, or this one what is that? Cutoff voltage or threshold voltage. For the case of silicon that is 0.7, for the case of germanium that is 0.3. And here also I will tell you one trick for you. What is that? What is that? Any idea about the trick? S for silicon and then S for 7. Yes, very good. You only said that. Correct only. S for silicon and then S will be 7. That is very bad actually. I will take G as a 7 right number. So G, 7 will not come for the G, it will come for the silicon. Adhe chennagide na first day. That is about the forward bias. Reverse bias I will explain. First of all, copy that. Forward bias. क्या रहता है बस? 3 कहाँ है? यस को रिवर्स लिखे तो 3 होता, हमारा गो में तो नहीं आता. हो गया? बोलो बोल. Right, forward bias. ಅಮ್ಮ ಟ್ರಿಕ್ಸ್ ಅಂದರೆ ಬರೇ ಟ್ರಿಕ್ಸ್ ನೆನ್ಪಿಟ್ಕೋಬೇಡ್ರಿ, ಕಾನ್ಸೆಪ್ಟ್ ನೆನ್ಪಿಟ್ಕೋಬೇಕು. So you are remembering all the tricks like that only. Whatever the formulas I am saying, everything problems also. Draw that graph first. ದೇವರಾಜ ಹೋಗಿ ಮತ್ತೆ ಇಂಕ್ ಹಾಕೊಂಡು ಬಾ. That should not come out. लेके लेकर ब्लू का नहीं है. Write that. In forward bias, existing electric field due to the diffusion, in forward bias, existing electric field due to the diffusion gets dominated by external electric field by the battery and the barrier potential overcome by the external potential up to a limit of voltage current increases slowly with the voltage. After that voltage, it increases drastically even for the smaller change in voltage. This voltage is known as knee voltage, cutoff voltage or threshold voltage. Whether for the silicon 0.7, for the germanium 0.3. And now from this point only, from 0.7 volt only, the current will increases. Next, reverse bias. See here, I have taken reverse current. Always the current will be in reverse current, so only I have drawn in the negative axis. Now here in the reverse bias, we will have one voltage is known as a breakdown voltage. What is that breakdown voltage? We will see first of all. We know already in the reverse bias, current flow will be due to what? Due to the minority charge carrier. Less or more? Very less in terms of microamperes as well as nanoamperes. In the case of silicon, that is in nanoamperes. In the case of germanium, that is in microamperes. So very less current. Up to what happens means, if you see this graph, here what happens initially, what happened little bit, it is increasing. Initially straightly it was there, nothing much straight line was there, both are proportional. Whenever I increase the voltage, immediately the current also increases for even zeros, in terms of zero values. Now what I am taking here I am saying that whenever I increase the voltage, even in that also, whenever you see this graph, you can say almost current is constant. See that I have just drawn a straight line like that, almost straight line. So what I can say means, up to it reaches the breakdown voltage, the reverse current will be very small. After this breakdown voltage, what happens? Nothing but I am just further giving the voltage from outside. The voltage will be 25 volts for the germanium actually. Up to that much of value I have to give. 25 volts is very big voltage whenever you do this experiments. Now whenever I give the voltage, I am increasing the voltage, I am keep on increasing the voltage from 0. Then what happening up to 25, nothing is happening, I am getting very less current. Let me take 0.01 microampere, like that I am getting very less current. That was constant, that was continuously constant, it is not changing anymore. Then whenever I reaches the 25 volts, at that time what happening, immediately I can see a drastic change in that, it is coming, this one is increasing like this. Now here only within this much of smaller change in voltage, nothing but 25, 26, 27, 27, like that I am increasing, then what happening, nothing but current is increasing this much. So this voltage is known as a breakdown voltage. What it is breaking, nothing but it is breaking the covalent bonds. It is breaking the covalent bonds between the hole and then electron pair. Up to there what happening, due to the minority charge carriers only current was flowing. So minority charge carriers was very less, so current was also very less. Then after that what happening, nothing but whenever I am giving the extra battery outside from there, then here I am giving the battery, nothing but what I am giving there, energy. I am giving that energy. By using that energy, what happening, nothing but the external energy is more than the covalent bond. Covalent bond is there already, as compared to the covalent bond, my external energy is more. So what happening, nothing but the electrons and then holes are gaining that external energy and then they are breaking the covalent bond. Whenever they break the covalent bond, there are more number of free charge carriers here. So what they will do, they will obviously diffuses. So only by that we are getting the extra current here. Huge current we are getting for even smaller change in the voltage. You understand the mechanism, right? So here, why breakdown, nothing but it is breaking the covalent bonds. Up to 25 covalent bonds are not breaking. Whenever I increase the voltage to 25, then what happening, nothing but covalent bonds between the ions is getting breaked. Whenever it is getting breaked, all are free from each other, bond is not there, then what they will do? Obviously they will get diffused. So due to that more number of free electrons, before very less was there, those are what? Minority charge carriers, by that I am getting very less current here. Whenever I break the bond between them, now more number of free charge carriers are there. That free charge carriers gets diffused, large number of free charge carriers will be there, so only I am getting here extra current. Even for the small change in the voltage, I am getting the extra current here. And also in this, for the germanium, the breakdown voltage is 25 volts. For the case of germanium, it is 25. And then for the case of silicon, that will be 35 volts. Whenever you see in both the cases, germanium is 0.3 and then silicon is 0.7. Here also, the germanium is 25 and then silicon is 35. Always the silicon will have high values as compared to the germanium. You have to remember that. You should not confuse between them. So you are taking in the forward bias, germanium less. Even in the reverse bias also, germanium is less only. In the forward bias, silicon is more. How much that is? 0.7. In the case of reverse bias, that is 35 we will take. Okay, that is about the germanium and then silicon values. However, but the breakdown voltage nothing but up to which covalent bonds will be there, and then we will get the current due to only minority charge carriers. After the breakdown voltage, what happens, nothing but covalent bonds will get breaked, and then there are more number of free electrons and then free holes will be there. They got divided from the bonding. So that a huge number of free electrons will be there and then free holes will be there. Due to the diffusion process, we will get a current, we will get a high current like this. So that is known as what this limit of voltage is known as a breakdown voltage. In this breakdown only, we will have two types again. That is, one is Zener breakdown, another is the avalanche breakdown. So what is a Zener? Just definitions matters, that's it. Definition is also important. In that one point will be there, in which kind of doping will get which kind of breakdown voltage. Whenever you see the Zener breakdown, will get whenever highly doped PN junction is there, then Zener breakdown will be there. Whenever you take the lightly doped PN junction, at that time avalanche breakdown will be there. That point is very important. Now here in this breakdown, first of all Zener breakdown we will discuss. So what is the Zener breakdown? Nothing but I said already, in the reverse bias what we are doing, nothing but we are giving the external voltage. That external voltage was supporting the electric field. Do you remember that? External voltage was supporting the electric field. At that time what happening? Barrier potential is increasing. Width is increasing, barrier potential also increasing only. Due to that high potential, whatever the charge carriers are there, they are getting more energy. So by getting more energy, they will break their bonds. then what happens, the current whatever is flowing due to that is known as the Zener breakdown voltage. What is the avalanche breakdown? Nothing but avalanche breakdown means whenever you see in the reverse bias, again this one potential is increasing only. By using that energy, what happening, nothing but that whatever the free charge carriers are there, they are moving randomly inside of the PN junction. Whenever they are moving randomly, at that time what happen? Collision. Whenever charge carriers are moving randomly, at that time what happens? Collision will be there. Due to that collision, avalanche breakdown will come. Clear? Due to the breaking the covalent bonds, what happens? Zener breakdown will come. After that, after breaking the covalent bond, all are free from each other and then they are moving randomly. At that time they will collide with each other. That breakdown is known as a avalanche breakdown. And also the Zener breakdown will happen in highly doped PN junction. Highly doped PN junction. This one is happening in the lightly doped PN junction. Lightly doped and then highly doped PN junction. That is about the reverse bias. In reverse bias, mainly we know that already whenever we are connecting the reverse voltage, at that time it is increasing the barrier potential. It is supporting the existing electric field. But here in this case, what happening? It was opposing the electric field and then overcoming the which voltage? knee voltage. After that only it is happening. What happening here? Current is increasing. Then in the whatever the reverse bias we have taken, initially up to the barrier potential, nothing but up to the covalent bond breaking, up to that what happens, nothing but the current flow is there only due to the minority charge carriers. Already we know, I said already drift current and then break the reverse bias mechanism also. So in that the current flow will be there only due to the minority charge carriers. Everybody was bonding at that time. So no free electrons, no free holes was there. Now what happening, whenever I am further increasing the voltage, then what happens? They will gain the energy to break the bond. Once they break the bond, they are free from each other, they can move easily, and then whenever they are moving, at the time whenever they are moving in the lightly doped PN junction, at that time what happens? Collision will happen. Due to that, which breakdown will come? Avalanche breakdown. In the highly doped PN junction, whenever they got breaked the bonding, at that time they will move and then they will give the what is that? Zener breakdown voltage in a highly doped PN junction and then the lightly doped PN junction. So this is not much difference. Both are same only. Covalent bonds will break in the Zener breakdown and then after that they will collide in which breakdown? Avalanche breakdown. Due to the collision, avalanche breakdown. Due to the breaking of the covalent bonds is Zener breakdown. Now after they break the covalent bonding, at that time more number of free carriers are there. Due to that free carriers diffusion, we will get the current here. More current will get. This whatever the limit we are having, that voltage is breakdown voltage. What it is breaking? Covalent bonds between the electron hole pair. Clear? So that is about the reverse bias, right? That reverse bias. And for germanium the value is 25, for the silicon it is 35. In reverse bias, due to the applied reverse voltage, due to the applied reverse voltage, due to the applied reverse voltage, the barrier potential increases, barrier potential increases, barrier potential increases, and by further increase in the voltage, by further increasing the voltage, breaks the covalent bonds between electron hole pairs, break the covalent bond between electron hole pair, and large number of free carriers participates in further diffusion. Participates in further diffusion. Participates in the further diffusion. This voltage is known as breakdown voltage. This voltage is known as breakdown voltage. In that first you write Zener breakdown voltage. Occurs in highly doped p-n junction. Occurs in highly doped p-n junction. Occurs in highly doped p-n junction by the diffusion of free charge carriers. By the diffusion of free charge carriers. By the diffusion of free charge carriers. Diffusion of free charge carriers after breaking the covalent bonds. After breaking the covalent bonds. Next one, avalanche breakdown. You underline that highly doped p-n junction for the Zener breakdown. Next, avalanche breakdown occurs in lightly doped p-n junction. Occurs in lightly doped p-n junction due to the collision of free charge carriers after breaking the covalent bonds. After breaking the covalent bonds. After breaking the covalent bonds. ऊपर करंट फ्लो का बोली कुछ में ಕಾಣಿಸ್ತಾನೆ ಇಲ್ಲ ಅದು ಕೊಡು ಯುವರಾಜ. ಎಲೆಕ್ಟ್ರಾನ್ ಹೋಲ್ ಪೇರ್ large free electron content personal further diffusion this one. क्या रे मैडम को स्पेक्स देना बोल रहा. Right. After this breakdown voltage, in the next line you write, after this breakdown voltage, even for the smaller increase in the voltage, gives larger reverse current. Gives larger reverse current. ಕಾಪಿ ದ ಡಯಾಗ್ರಾಮ್. ನೋಟ್ಸ್ ತುಂಬ ಇದೆಯಲ್ಲ ಈ ಟಾಪಿಕಲ್ಲಿ. ಸೆಮಿಕಂಡಕ್ಟರ್ ಭಾಳ ನೋಟ್ಸು. ನಿಮ್ಮ ಥರ ಪಾಪ ಉದಯ್ಕಂದರೆ ಇಷ್ಟ ನೋಟ್ಸ್ ಬರೆಯೋಕ್ಕೆ, ಅದಕ್ಕೆ ಹೀ ಈಸ್ ಎಂಜಾಯಿಂಗ್. ಅಷ್ಟೇ, ಪಿ ಎನ್ ಜಂಕ್ಷನ್ ಮುಗೀತಂದರೆ ಮುಗೀತು ನೋಟ್ಸು. ನೆಕ್ಸ್ಟ್ ರೆಕ್ಟಿಫೈಯರ್ಸ್ ವಿಲ್ ಬಿ ದೇರ್, ಇನ್ ದಟ್ ನಥಿಂಗ್ ವಿಲ್ ಬಿ ದೇರ್, ಆ್ಯಂಡ್ ದೆನ್ ಈವನ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ಸ್ ಆಲ್ಸೋ, ಡೈರೆಕ್ಟ್ಲಿ ಫಾರ್ಮುಲಾಸ್ ಓನ್ಲಿ. ಡ್ರಾ ದಟ್ ಆ್ಯಂಡ್ ವಿಲ್ ರೈಟ್ ಎ ಟೇಬಲ್. ಸ್ವಲ್ಪ ಜನ ಏನು ಅನ್ಕೊತ ಇರ್ತಾರೋ ಗೊತ್ತಾ, ಇವರು ಎಲ್ಲ ನೋಟ್ಸ್ ಹೇಳಿದಾದ್ಮೇಲೆ ಟೇಬಲ್ ಹೇಳ್ತಾರೆ. ಫಸ್ಟೇ ಟೇಬಲ್ ಹೇಳಿದ್ದಾರೆ ಅಂದರೆ ನೋಟ್ಸ್ ಬರೆಯೋಕ್ಕೆ ಅವಶ್ಯಕತೆ ಇಲ್ಲಲ್ಲ. ಕರೆಕ್ಟಾ ಉದಯ್? ಏನು ನೀವು ಆ ಟೇಬಲ್ ಅನ್ಕೊತ ಇದ್ದೀವಿ. ಏನು ಪ್ರಮೋದ್ ಎಲ್ಲಿ ಕಳಿಸಿದ್ವಿ ಶ್ರೇಯಸ್ಗೆ? ನಾನು ಈ ಹೆಸರು ನೋಡಿದ್ದೀನಿ, ನಾನು ಶ್ರೇಯಸ್ ನೀವು ನೆನಪು ಬಂದಿದ್ರು. right? Connection in forward bias, which connection will be there? What is the connection of forward bias? Positive terminal to positive terminal to P and negative terminal to N. ಏನು ಆಗಿದೆ ನಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೆ ಪಾಪ, ಅಯ್ಯೋ ಪಾಪಂ, ಏನೋ ಆಗಿದೆ ಎಲ್ಲರಿಗೆ. ಏನು ವರುಣ್ ಬಾಬಾ ಏನು ಮಾಡಿದ್ರೆ, ಏನು ಮಂತ್ರ ಹಾಕಿದ್ರೆ ಏನು ಎಲ್ಲರ ಮೇಲೆ? ರೈಟ್. ಕರೆಂಟ್ ಫ್ಲೋ ಇನ್ ವಿಚ್ ಡೈರೆಕ್ಷನ್? P to N. Current flow will be in P to N, and which current is more here? Diffusion current is more as compared to the drift current. And next, current in terms of what? In the range of what? Forward biasing nothing but milliamperes. And then resistance, forward resistance, Rf is equals to, what is the formula you will write? Delta Vf by If, that is equals to in 100 ohms approximately. Depletion layer width will decreases, potential also decreases, and the voltage, which type of voltage will be there? Which voltage will be there in this? In characteristics amma, VI characteristics, which type of voltage will be there? knee voltage is there. ರಾಮಾಯಣಂ ಎಲ್ಲ ಕೇಳಿ ಅದೆಲ್ಲ ರೊಟೀನ್ ಡೈಲಾಗ್ ಅದೇ. ನೀ ವೋಲ್ಟೇಜ್ ಏನು ರಾಮಾಯಣಂ ಎಲ್ಲ ಕೇಳಿ ಕೃಷ್ಣನಿಗೆ ಸೀತಾ ಏನಾಗುತ್ತೆ ನಂದಂತ ಏನು ನಮಗೇನು ನೆನಪು ಬರ್ತಾಯಿಲ್ಲ. ಥ್ರೆಶೋಲ್ಡ್ ವೋಲ್ಟೇಜ್. ಥ್ರೆಶೋಲ್ಡ್ ಸ್ಪೆಲ್ಲಿಂಗ್ ಬರ್ತಾಯಿಲ್ಲ, ಬರ್ಕೋರಿ ನೀವೇ. This value for the germanium is what? Germanium and then silicon. Germanium is 0.3, silicon is 0.7. ನೆನಪಿಟ್ಕೋರಿ, ದೀಪಿಕಾ ಲಾಜಿಕ್. Right, connection now in the reverse bias. Positive terminal to N and then negative terminal to P we will get. And then current flow from where to where? N to P. And then which current will be more here? Drift current is more than the diffusion current. Then current will be in terms of what? Microamperes for the case of germanium, nanoamperes for the case of silicon we will get. Next, reverse resistance. R reverse is equals to delta V reverse by delta I reverse. What is the value? 10 power 6 ohms. Then depletion layer width will increases, barrier potential also increases. Then voltage will be which voltage here? Breakdown voltage. Breakdown voltage. Then that value will be for the case of germanium, that is 25 volts, and then for the case of silicon, that is 35 volts. That is about the everything whatever we have discussed yet. ಫಿನಿಶ್ಡಾ? ಏನು? ಹಾಂ, ಐಡೆಂಟಿಫೈಯಿಂಗ್ ಏನು ಐಡೆಂಟಿಫೈಯಿಂಗ್ ಬಯಾಸಿಂಗ್. ಪಿ ಅನೇ ಥರ ಇದೆನಾ ಅದೇ? ಬಿ ಅದೇ ಓಕೆನಾ? ಇವಾಗ ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ನಿಮಗೆ? ಆ ಥರ ಆನಿಮುತ್ಯಲ್ಲಿರುತ್ತೆಪ್ಪ, ನೀವು ತೊಗೋಬೇಕಾಗುತ್ತೆ. ನಿಮ್ಮ ರೈಟಿಂಗ್ ಅದೇ, ನಮ್ಮ ರೈಟಿಂಗ್ ಸೋ ಫಾರ್ ಬೆಟರ್. ನೀವೇನು ಹೇಳೋಕ್ಕೆ ಏನು ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಫಿನಿಶ್ಡಾ? And sir is thinking to take combined class, sir. Kishore sir, 5:30. Will you okay with that? Evening, you will not be okay for anything, you know. Will you okay? Otherwise I will take the study hour. My study hour is there actually. Whenever he is taking the class means tomorrow I will take the study hour. Chemistry study hour only. However, tomorrow I will take that. If not, what happens means you can listen the class and then I can take the study hour tomorrow, or not I can continue my study hour and then he will take the tomorrow only classes. ನಿಮ್ಮ ಆಪ್ಷನೇ ಅದೇ, ಫಸ್ಟ್ ಆಪ್ಷನ್. ಸೊ ದಟ್ ಯು ಲಿಸನ್ ದ ಕ್ಲಾಸ್, ಕಂಬೈನ್ ಕ್ಲಾಸ್. ಸ್ಟಡಿ ಅವ್ರು ಬೇಕಾ? ಅರೆ ನಿಮಗೆ ಲೈಫಲ್ಲಿ ಏನೂ ಬೇಡ. ಫಸ್ಟ್ ನೀವು ನಮಗೆ ಬೇಡ, ಫಸ್ಟು ಎಲ್ಲ ಹೋಗು, ಹೊರಗಡೆ ಹೋಗು. ರೋಡ್ ಮೇಲೆ ಓಡಾಡೋಕ್ಕೆ ರೆಡಿ ಇರ್ತವೆ ನೀವು. ಸೊ ಹಿಯರ್ ಟೆಲ್ ಮಿ ವಿಚ್ ಬಯಾಸಿಂಗ್ ದಿಸ್ ಈಸ್? ರಿವರ್ಸ್ ಬಯಾಸಿಂಗ್. ಶೂರ್ ಅಬೌಟ್ ದ್ಯಾಟ್? ನೌ see that. Now I will tell you the short trick to remember how to solve this kind of problems. And always you remember that 3 times they have asked only one problem. 3 times. 2016 or something, 2016, 2012 and then 2004, like that they asked. 3 times only one question. In NEET history never happened in case of physics. But this break that whatever the record it was having. So that problem is very very important. I will tell you the short trick to remember that. You just remember the short trick and also along with that heading. ಸ್ವಲ್ಪ ಹೆಡ್ಡಿಂಗ್ ಕೂಡ ನೆನಪಿಟ್ಕೊಡ್ರಿ. ಬರೇ ಶಾರ್ಟ್ ಟ್ರಿಕ್ ಅಂದರೆ ಅದು ಕೂಡ ತುಂಬ ಶಾರ್ಟಲ್ಲಿ ಮಾಡಿ ನೆನಪಿಟ್ಕೊತಾ ಇದ್ರಿ ನೀವು. ಅದು ಏನಕ್ಕೆ ಹೇಳಿದ್ರು ಅವರು, ಯಾವ ಚಾಪ್ಟ್ರಲ್ಲಿ ಹೇಳಿದ್ರು ಅನ್ನೋ ಅಟ್ಲೀಸ್ಟ್ ನೆನಪಿಟ್ಕೊಡ್ರಿ. ಶಾರ್ಟ್ ಟ್ರಿಕ್ ಅಂದರೆ ಅಮೇಝಿಂಗ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಈ ಪೀಪಲ್ ಆರ್. So this is the P and then N I have taken. Whatever the voltage we have applied for the P, I will take it as Vp, and then for the N that is Vn. Now by using the difference between the Vp and Vn, we can identify which biasing that is. Sometimes it will be unbiased also. So here Vp minus Vn is equals to 0, that is unbiased. Unbiased nothing but there is no change in the potential difference. Potential for the Vp is same as the potential for the Vn also. Nothing but here 60 means here also 60 volt only there. Is there any current flow in that? There is no current flow possible in that. So only the PN junction is unbiased. Next one is whenever Vp minus Vn is positive, then it is which biased? Forward biased. Whenever Vp minus Vn is negative, then it is which bias? Reverse bias. That is about you have to remember mainly. For the case of always they will ask, very very important. In PN junction very simple, they will not ask the numericals. If they are asked also, they will ask based on this only, forward and then reverse bias only. In the reverse bias what happens nothing but current flow will not be there. Current flow will be already you know that due to the minority charge carriers in terms of nano amperes it will be there. So that the current flow will not be there in the case of reverse bias. Only in the forward bias only the diode will conduct. And also one more concept will come, that is ideal diode. In some of the problems they will ask that as ideal diode or steady state like that. So here steady state nothing but what happens, that whatever the capacitor they have given, otherwise inductor they have given, steady state nothing but that will blocks the current. Current will not flow in that. I is equals to 0 we have to take. You have to remember that mainly. So steady state, in some of the problems they will ask like that. Steady state nothing but in that current flow will not be there. Okay, that is about the steady state. Now here one more concept will be there, that is a ideal diode. What is that ideal diode? Nothing but ideal diode is like no diode only. Nothing but it does not draw any current. So whatever the current is coming, it is just passing that current. It is working like a wire only. Ideal diode means it is not already you know that ideal potentiometer, ideal voltmeter. What happens? Ideal voltmeter means it does not draw any current. That is what we have taken. And the resistance was how much? Infinity we have taken. So in the case of ideal diode, nothing but ideal diode means no diode only. You just forget that diode and then you just do the whatever the problem as it is like a KVL and then KCL only. So that is about the ideal diode concept. Whenever we solve the problems, then you will get this word. And also this is a short trick for solving the what is that biasing concept. Copy that and we will do the problems. Figure shows a diode connected. Copy fast. Figure shows a diode connected to an external resistance and an EMF. Figure shows a diode connected to an external resistance and an EMF. Assuming that barrier potential developed in diode is, why barrier potential developed they are saying? Why it is developed? What is the barrier potential? Nothing but before connecting the battery, what happens due to the diffusion process? What happens? Due to the diffusion process, what happens? Depletion layer will have some electric field. Due to that electric field only this barrier voltage came. So only it is developed. We are not forming anything out from outside. We are not giving anything from outside. After that only I connected this battery. How much battery? Nothing but here 4.5 volts battery. So only the barrier potential is developed there. So barrier potential developed in the diode is 0.5 volts. Obtain the value of current in milliamperes. Obtain the value of current in milliamperes. बोर्ड रख कुछ नहीं होता कौन भी नहीं देते What answer? 40 milliamperes. 1 by 25 or yes? 1 by 25 is the correct answer. Four by 100 you will get, that's it. That's the answer. Yes. 4 by 100 is the correct answer. See that here external potential is how much? 4.5 volts. How much PN junction is drawing? 0.5. So how much voltage is remaining for us? 4 volts. That is what you have to understand mainly. Some of the people might be having that extra curricular not curricular activities, what we can say, extra knowledge, and then they will do 4.5 plus 0.5 is 5, and then 5 by 100 is 1 by 20, like that you might be getting. Correct, Babaji? So here you will get this as 4.5 voltage, and then it is drawing how much? 0.5 volts. Then what is the voltage? You will get nothing but current is equals to, what is the formula for us? Voltage by the resistance, and the voltage is nothing but V minus barrier potential, that divided by R. That divided by R here. So that here V is how much? 4.5 minus barrier potential is 0.5 divided by R is 100. Then how much you will get? 40 milliamperes. In terms of milliamperes only I ask the question. Yes sir. So here 0.5 indicates the PN junction drawing that voltage. That's it. Next question. వీడియో ఆన్లో ఉందమ్మా, ఆఫ్ చేసారా, పాస్ చేసారా? హలో సార్. సార్ కాల్ చేశారు. లేదు సార్, క్లాస్లోనే ఉంది, చెప్పండి. అవునా సరే, అయితే ఒక పావు గంట అంతే కాల్ చేస్తాను. సరే సార్. Finished? Next problem. If the current in the given circuit is 0.1 ampere, if the current in the given circuit is 0.1 ampere, then calculate the resistance of PN junction. Then calculate the resistance of PN junction. Five volts battery, yes, find the resistance of PN junction. Don't think much, in the surface level only you will get the answer here, very easy. It not given. How much? ಯಾಕೆ ಅಷ್ಟು ಏನು ಮಾಡಿದ್ಯಾ ನೀವು? KVL ಅಪ್ಲೈ ಮಾಡಿದ್ಯಾ? 10 is the answer. Very good Anna. 10 is the answer. I is equals to V by R. I is equals to V by R you have to take. Ten ohms is the correct answer. You should not take this much time for that. Very easy problem. See that here you just consider what they are asking finally. Resistance of the PN junction, right? So that you just assume that PN junction has only resistor. That's it. Finished. Problem is finished. They are not given any barrier potential here. Nothing but the barrier potential is negligible as compared to the external voltage. So you just make it as a resistor only. Make this one only as a resistor. Let me take the resistance of the PN junction is R. Now what is the current here? I is equals to what we get? V by R. Voltage is how much? 5. That divided by total resistance is in which combination? Series. This is 30. You have taken that as 3. Wrong. 30 and then 40. 30 and 10. Can't you see that 30 is there? ಅವಾಗೆ ಆನ್ಸರ್ 10 ಬರುತ್ತೇನಾ? 10 ಮತ್ತೆ ಆನ್ಸರ್, ಅದಕ್ಕೇ ಹೇಳಿದ್ದೀನಿ. 30 ಇದೆ, ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ನಿಮ್ಗೆ ಎಲ್ಲರಿಗೆ ಪಾಪ ಸೈಡ್ ಬಂದು. Finished. Answer is finished. If not, what is the answer? 13. That will be 13 and then 50 minus 13 is 40. 37. 37 ಬರುತ್ತೆ. 47 ಇಲ್ಲ, 37 ರೀ. 50 minus 13 ಎಷ್ಟು? ಅದಕ್ಕೆ ಬಬಲ್ ಗಮ್ಸ್ ಜಾಸ್ತಿ ತಿನ್ನಬಾರ್ದು. ಮುಗಿತಾ? Before that 37 is the answer. You got that? That is wrong answer. 10 is the correct answer. Clear? That is about that problem. Nothing but diode can have the resistance also. They will ask the problems like this also. The next problem. What is the value of current in the given circuit? Just observe the circuit properly, that will only give you the answer. What is the answer? 4 by 3. Then anything else? ಅಷ್ಟೇನಾ? ಅದೇ ಪಿ ಎನ್ ಜಂಕ್ಷನ್ಗೆ ಏನು ಮಾಡಿದ್ಯಾ? ರೆಸಿಸ್ಟರ್ ಥರ ತಗೊಂಡಿದ್ದೆ. ಎಷ್ಟು ರೆಸಿಸ್ಟರು ಯಾರು ಕೊಟ್ಟಿದ್ರು? ಅಲ್ಲಿ 10 ಕೆಳಗೆ ರೆಸಿಸ್ಟರ್ ಇದೆಯಪ್ಪ ಅಲ್ಲಿ. ದಟ್ ಇಸ್ ಅ ರೆಸಿಸ್ಟರ್. ಆಲ್ರೆಡಿ ರೆಸಿಸ್ಟರ್ ಎಕ್ಸಿಸ್ಟ್ ಹಿಯರ್. ನಿಜನೇ ನಿಮಗೆ ಎಲ್ಲ ಕಣ್ಣು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ. ಪ್ರೋಟೀನ್ ಕಡಿಮೆ ಆಗಿದೆ ಫುಡ್ಡಲ್ಲಿ. ಹಾಂ, ಅದು ರೆಸಿಸ್ಟರೇ. ಆನ್ಸರ್ ಈಸ್ 1 ಆಂಪಿಯರ್. ಎನಿಬಡಿ ಗಾಟ್ ದಟ್? Very good. 1 ampere is the correct answer. One ampere is the correct answer. ಯಾಕೆ 1 ampere ಬಂತು ಹೇಳು? ಯಾವುದು ಸೀರೀಸ್ ಮಾಡಿದ್ಯಾ? 10 ಈ ಎರಡು ಪ್ಯಾರಲಲ್ ಇದ್ದಾವೆಲ್ಲ. 15. ಮತ್ತು ವೋಲ್ಟೇಜ್ ಎಷ್ಟು? 20 ವೋಲ್ಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ. 20 ಹೆಂಗೆ ಬಂತು? 15 ಬಂತಲ್ಲ. 20/15 ಬಂತಲ್ಲ. 20 ಹೆಂಗೆ ಬಂತು? ಎನಿ ಅದರ್ ಆನ್ಸರ್? ವಾವ್, ಗ್ರೇಟ್. ಟಾಪರ್ ಯುವರಾಜ. ಈಗ ನೋಡ್ರಿ, ಇದು 10 ವಿಚ್ ಕಾಂಬಿನೇಷನ್? ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಕನೆಕ್ಟೆಡ್ ಟು ದ ಸೀರೀಸ್. ಸೊ ಎಷ್ಟು? 15. 20/15 ಈಸ್ 4/3. ರಾಂಗ್ ಆನ್ಸರ್. ರಾಂಗ್ ಆನ್ಸರ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ, ರಾಂಗ್ ಆನ್ಸರ್. ನೀವು ಕರೆಕ್ಟ್ ಅಂದರೆ ಅದು ಕರೆಕ್ಟ್ ಆಗಲ್ಲ. ದಿಸ್ ಈಸ್ ಅ ರಿವರ್ಸ್ ಬಯಾಸ್. ದಿಸ್ ಈಸ್ ಇನ್ ರಿವರ್ಸ್ ಬಯಾಸ್. ಚೆಕ್ ದಟ್. ಹಿಯರ್ P is connected to what here? Negative terminal. Here N is connected to positive terminal. So this is in reverse bias. In this there is no current flow. So what happens? The current will come from here to here, here to here, here to here, like this it will go. Correct? Now what is the answer? 1 ampere is the correct answer. So in your options, whatever you said, that is 4/3 also will be there. That's wrong. ಅವಾಗ ಮಲ್ಟಿಪಲ್ ಆನ್ಸರ್ ಈಸ್ ಪಾಸಿಬಲ್ అని ಬರ್ತಾರೆ. ಮತ್ತೆ 1 or 2 ಕೊಡ್ರಿ ಮೇಡಮ್ ಅನೇ. ಅರ್ಥ ಆಯ್ತಾ ಪ್ರಾಬ್ಲಮ್? This is in reverse bias. So only I said that much of statrics and all, and then I have shown you the connections. Even then you did not think about that. ಯುವರಾಜರಿಗೆ ವೆರೈಟಿ ಆನ್ಸರ್ ಬಂತು ಮತ್ತೆ. ಹವೆವರ್ ಆನ್ಸರ್ ಇಸ್ ಸೇಮ್ ಓನ್ಲಿನಾ? ನಮಗೆ ಆಪ್ಷನ್ನೇ ಬೇಕು, ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಯಾರಿಗೆ ಬೇಕಂತೀವಿ. ರಿವರ್ಸ್ ಬಯಾಸಲ್ಲಿ Yes, in terms of nanoamperes it will be negligible. And reverse bias nothing but you should not take that. మనం నోరు మూసుకోకపోతే గుండు పగిలిపోతుంది నీకు. What is the value of current in the given circuit? Next, what is the value of current in the given circuit? What's the answer? What is the question you are asking? Current flowing in the circuit. I value is how much? 3 by? What is the current flowing in the circuit? Very good, very good. 2 milliamperes is the correct answer. Yes. What is the reason? Which is in reverse bias? Germanium. Germanium is in reverse bias. See that here positive is N is connected to positive terminal and then P is connected to the negative terminal. So this is in reverse bias. Whenever the PN junction problem is given, you search for the reverse and then forward bias first of all. Then immediately you remove the reverse bias voltage and whatever the diode, and then you find the remaining answer. So this was in reverse bias. There is no current flow in this. Then what happens? Current flow will be there only in this direction like this. Now already this is drawing how much of voltage here? 0.7. Then I is equals to 2.7 minus 0.7, that divided by how much? 1000. Then what is the answer you will get? 2 milliamperes. That is the current I. Clear? Next problem. In the given circuit, if PN junction is ideal, in the given circuit, if PN junction is ideal, calculate the current flowing through that. Hey. Ideal andre nanu ideal andre it will act like a wire only. Yara power ಅಷ್ಟು ಫಾಸ್ಟ್ ಬಂದೆ ಆನ್ಸರು. ಕರೆ ಸೈಫ್ क्या खाया दोपहर में? Wait, first of all I'll check the voltages. 103 correct. Ideal PN junction. Ideal PN junction nothing but it will passes the current very freely. It will act like a wire only. I said there is no need to take the PN junction. I said I did not say that there is no need to take the current. Correct, Saif? What is the current flowing through that? You will get the answer by the KVL also. You can apply and then you can get the answer. How much? Yes, very good. 0.1 you will get 0.1 amperes, 0.01 ampere I think you will get. 0.01 you will get. Correct? See that by using the KVL also you can get the answer. But I will not say that. I will tell you in the normal PN junction method only. I said that ideal PN junction. Ideal nothing but what I said, there is no need to take the diode. If ideal diode nothing but I said no diode. Okay, no diode nothing but you will get a connecting wire like this, and then here resistor R is there. Here the voltage 1 volt is there like this, and then 3 volts is there like this. This is the equivalent circuit I drawn. Correct? This is 1 volt and then this is 3 volts. And now this is our 200 ohms resistance here. Now what happening means, whenever I connect the batteries in the opposite polarities, then what happens? What will you get? Net EMF is how much? E1 minus E2 na, otherwise E1 plus E2 na? E1 minus E2. Here E2 is greater, so that what will get here? E2 minus E1 you will get. So the net voltage here is how much? Nothing but only 2 volts. Now the 2 volts also will be there in this direction. In whichever the direction the battery with more voltage is there, in the same direction net voltage will be there. So this is the 2 volts here, and then this is a resistor of how much here? 200 ohms. Then current flow is how much? 0.01 amperes, or I can say this as 10 milliamperes. That is the answer by using the normal method. If not, I want to apply the KVL. For that, whenever I am traveling my journey from here, so here to here I am going from the higher potential to lower potential. Then what will get? Minus 1. And then here nothing is there. Here in the resistor what will get? Minus I into 200. And then coming from the lower potential to higher potential, what will get there? Plus 3 is equals to coming to ground only again. Starting from ground, coming from ground, coming to ground only. Then what happens here? I is equals to again 0.01 only. Clear? 2 by 200 you will get. Anyhow you can solve, and then you have to get the answer. Now the previous year question. And then we will solve these theoretical problems also based on the PN junction. Almost in all the previous years they have asked the theoretical questions only. We will solve that also. That we will solve tomorrow, but now for today you just write this problem. Which of the following represents forward bias? Three years repeated question. This one is first one. Options only right. Tell me in which case, in each case what is the biasing here? Which one is forward bias? Third option or fourth option? This is a 5 here. ಏನು ಅನ್ಕೊಂಡಿರಿ ನೀವು 3 ಅನ್ಕೊಂಡಿದ್ದೀರಾ? 5 also only. Which option is the correct answer? Fourth option is the correct one. Why you said third option? 1 ohm ಅನ್ಕೊಂಡಿದ್ದೀರಾ? ಎಲ್ಲಿ ಇದೆ? ಬಾ ಖುಷಿ. I am feeling very khushi by seeing your answer. So here that is a 5 volts here. Which is the forward bias here? Last one is a forward bias. See, first of all, first one let us check. What I said, Vp minus Vn is equals to how much? Vp is minus 4 minus of minus 3. How much you will get? Minus 1. Minus 1 nothing but which biasing? Reverse biasing. Less than 1 you will get as negative values, you will get as reverse biasing. Now this one is how much? Minus 2 minus 2. That is equals to how much? 0. Ellide minus, yeah, minus 4. Yes, reverse biasing. Then next one is 3 volts and then minus 5 you will get as how much? Minus 2, reverse bias. And then this one is 0 minus of minus 2. How much you will get? 2 you will get as forward bias. This question asked in 2017, 2006 and then 2000. 3 years repeated. Chalo, take break.